Okay, we stopped here yesterday, right? Clear or not? Have you gone through the notes and see what are the difference between these two diagrams? Okay, yesterday I asked you to see what are the differences between these two diagrams. Do you notice any? First diagram and the second diagram. Find the difference. Any different? Can I get some response? Do you notice any difference between these two process? PFD. Any different you notice? Product ratio. Which part? This is a production of vinyl methyl chloride, VCM. Vinyl methyl chloride. Any difference? Or no difference? Any response? Feedback? If you notice no difference, just say no difference. That's it. No difference. From the unit up, any difference? Any idea? No idea or no difference? No difference on the unit up, no difference. You see? Okay. Unit up, no differences. If you check one by one, you won't find any differences. Okay, but the difference, the why it use the terms versus over here is from the first diagram, you see there is output value for the HCl and VCM. Okay, there is output value. For the second part, it deleted the value. Okay, that's the difference. Why it deleted the value? Because here, they want to propose the new input with this value. Okay, so here is the new value, whereby the first diagram, the first process here, it is 400 and 900. So these are the outputs that will be produced. Okay, here, if they propose a new plant with this input, so you need to find out what are the outputs and is there any improvement need to be done for the process. Okay, so that's the meaning of this diagram. That's what it want to show. Unit op here, between these two, there's no differences. Okay, so you need to let's say you are being assigned to increase the production to this input. So is there any necessary to do the retrofitting, to do any optimization perhaps? Okay. Then how to conclude it? By using all these points. Okay, the one that I explained yesterday. Okay, all to this point. There are synthesis step and also the integration step. Okay, so these are the synthesis step. In design process, we have process synthesis, process integration, and optimization. Okay, these are the synthesis step. 5 main synthesis steps. The integration step, the one that we did yesterday, which involved this. Okay, this process integration. Okay, so these steps, these flows involve the process integration. Okay, let's say I ask you questions, I give you a situation, then the question asks you to integrate the process following the steps. So these are the steps on process integration. Okay, it can be an open-ended question. So you must know how to explain each of the steps. Okay, from the beginning, the task identification, targeting, generation of alternatives, okay, the brainstorming, this one, then selection, which process is much more feasible. Then choose one, analyze in depth for that process. Okay, for example, yesterday we do on the to increase the purity of your product. Let's say that is the base case to improve the purity of your product. So what are the process integration involved? Using this task, you should be able to explain each of the tasks. Okay. Now these are process integration. This part, synthesis step. Okay, synthesis step. There are two different definition and activities. Synthesis step, once you already from the selection process, you choose one, then you analyze. So once you analyze, this comes in the synthesis step. Okay, where you already come up with your BFD, then PFD, the detailed PFD. BFD is the simple process like mixing, reaction, filtration. So PFD, what are the mixing process involved? What are the unit of? Whether you need a mixer or what else? Okay, then reaction. What are the unit of involved? Reactor. What type of reactor? PFR, CSTR, or membrane reactor. Okay, then filtration, separation. What are the unit of involved? That is the detailed process design. PFD, process flow design. Okay, and PNID. What is PNID? Those who had gone to internship and do the design. What's the term PNID? Design. Diagram. Piping, pipe and instrumentation diagram. Right. Okay, that one involved once you install all the instrument for the control process. Control system. Let's say for the reactor, what are the control system that you require? Control pressure. What do you need to install over there? What are the instruments? So PNID is the overall complete diagram where the engineers usually refers to. Okay. Now, process integration, it involves three types of integration. It can be mass integration. Okay, routing the species throughout the process. Mass integration, it involves your process, your product, okay, throughout the process. Property integration, which it involves, let's say, for example, the stream, allocation and manipulation of the stream. You want to reduce stream or increase the stream number. So how you want to arrange the location, okay, the design. Then energy integration, identifying the energy targets and optimizing heat recovery and energy utility system. So it involves the energy. For example, on the heat exchanger, how do you want to do the energy integration? Okay. Okay, what does it mean by utility? Utility, the term utilities. Because later on in your PDP, you need to identify what are your utilities because you will need to calculate the cost later on. What do you understand of the term utilities? What does it mean by utilities? Anyone? Anyone? You can Google around. Don't just look at my face, waiting for the answers. Electricity consumption and energy consumption. Okay, part of it. The component, what does it need for electricity and energy consumption? To produce this electricity and energy, what do you need? Okay. Fuel, right? Other than that, they want to generate the energy, but fuel is not considered as the utility. Fuel, not all process plant. It depends to your process plant. If fuel is your raw material, then consider as your raw material. Fuel. Other than that, correct. Steam. Okay, steam to produce the electricity. Yes, cooling water. Okay, steam. Steam, cooling water, or some calls as chill water, to be used in the heat exchanger. Okay. Now that is utilities. That one should be considered in your economic analysis later on. That's why it depends to your how many cooler that you have, how many heater, how many heat exchanger do you have. Okay. Okay, I just want to highlight again the pillars, sustainability pillars, environment, society, and economy. Okay, these three. There are questions in previous semester that it asks you to explain the sustainability pillars by giving some example. Okay, so you should give your example and discuss the sustainable process design based on these three pillars. Okay, for example, production of BCM, how it can impact on these three pillars. The environment, how can it impact on the environment? Will it produce hazardous waste? Or if it produces hazardous waste, how can you treat it? Okay. Then the society, construction of the plant, existing of the plant, will it contribute to the society growth? Okay, society income, because residents around will get job from that plant. Okay, something like that. That also relate with the economy, growth of the economy of the neighborhood perhaps. So if you have a plant over there, it will also generate income to the residents around. Okay, and also to the country and also to the state, because when you have your product, you have your profit, then you will pay the tax. So it will make the economy growth whether increase or stable. Okay. Chapter 1 mostly will be more on the discussion. No calculation yet. Okay, because you need to understand the concept of the process design, process integration, and process optimization first. Mainly on the sustainable design. Okay. Okay, any question before I move to the next slide? You can always ask question. No issue. I will not bite you. Okay, ask question. Now we move to the design process. What are the steps? In chapter 1 here, there are a lot of steps, a lot of objectives, key consideration. Okay. Now the design process, there are steps in designing and retrofitting chemical process. First, to assess the primitive problem. What are the problems that you want to solve? Okay, we engineers are problem solvers. That's why if you want to set up a plant, you must make sure what are the problems that you want to solve. Let's say the VCM in the previous design, previous PFD, right? VCM, why you want to set up the plant? Because there is demand. There's demand. But who want it? Who want to buy? Why they want to buy? What they want to do? Okay, the VCM. So there is demand. You want to solve the problem to to solve the issue of shortage of product. Okay. Now, process creation. What are the raw materials? What are the unit ops? This one only the generating ideas, not go into details yet. Okay. Now, development of base case. After you come up with the ideas, the process, alternative process, the analysis, now you produce the process flow. How is the general process flow? From mixing, for example, mixing, reaction, separation. Okay. After you already come up with your base case, the general process flow, then only we come up with the detailed process synthesis. Okay. Then once you conclude your detailed process synthesis, then only you can figure out what are the control system that you want to install. For example, filtration. Do you need pressure control system for filtration? Do you need pressure control system? Yes, because it depends to what type of unit of separation that you use. If you use membrane separation, you need to push the solution in. That one you need to control the pressure. Okay, the flow. So not all unit op you need to install pressure, temperature, flow. That one is common. Okay, but not every unit op you need to install these three. Pressure, temperature, level. That one is common, okay? Because if you put all, the examiner will ask, what is the purpose to install it? Because every installation requires a cost. Okay, is it only suitable instead of to install pressure controller to control the pressure? Perhaps you can install the level controller, where you can play around with the level of the mixture. Okay. Now, after you come out with the control everything, then only you can design your equipment unit of how big, for example, distillation column. How big your distillation could be based on your feed volume, the loading volume. Okay, and then from there, how many stages that you require? What type of material that you require? Carbon steel, stainless steel. There are many types of material. And that one also involve the cost. Okay, and then can you optimize the process? Let's say heat exchanger. Can you optimize the heat exchanger network or not? To reduce from, let's say, 5 heat exchanger to perhaps 3. Okay. Then after you design, then only the startup can be start the construction. Can start the construction. Because once the construction start, there is no room for mistakes already. Okay. And then one of the important part is the environmental protection as well. Once you come up with your process in the initial part, you must consider the environmental protection. What are the waste that you produce? What are the products? is it affecting the environment or not? Okay, how it can affect the environment. Then also the safety considerations. How you can make sure your plant is safe. Safe to the workers, safe to the residents, safe to the environment. Okay. Now these are the range of areas involved in chemicals. So it is not limited to this process only. There are various of process. These are the examples. Okay. Here it mentioned, partly due to the growing awareness of the public, many design projects involve redesign or retrofitting of existing chemical process to solve the environmental problem and to adhere to stricter standard of safety. Current existing plant, so not all that is willing to do the retrofitting to meet to solve the environmental problem because it all involve cost. Okay, just to share, I have experienced a project with some company to retrofit their wastewater treatment. Okay, from the conventional method to not totally build new plant. We just want to retrofit somewhere. So we already propose the flow diagram, the solution, everything. At the end, the company reject because they mention of the budget issue. Okay, not all companies want to retrofit their waste treatment because waste doesn't bring any profit to them. Okay, usually the company will ask what profit will it bring if I retrofit the waste treatment plant. The main concern is their process where it produce their product. Usually maintenance, the facilities, and also the waste part, they don't want to invest much. Okay, as long as the waste can meet the standard, then should be enough. Okay. Okay, any question from here? Hopefully you can grasp what are the points that I mentioned just now. This one you can read on your own. Okay, now. These are the flow, basically, from the points just now. When you need to assess the problem first, then it's separated into these interconnected activities. The last part would be the detailed design. Okay, this one always the last part. Okay. Okay, these are the parts. It's separated into 4 parts from the flowchart over here. What is teh tarik doing over there? All of you drink teh tarik. No. Cut sugar. No money. Only drink warm water. Okay, why I put teh tarik halia here? Here teh tarik lah. Basil, do you drink teh tarik? Yes. Okay, why I put teh tarik here is I want to explain the concept of this part actually. By giving an example as teh tarik halia as the base case. Okay, as the case study lah. Let's say you have in Mamak stall, you want to increase your profit, your productivity, profit. So you want to know what are the products that you want to do, new product that you want to do, so that it can give more income. Okay, then one of the workers suggests teh tarik halia. Okay, new product, teh tarik halia. So that one is the primitive problem. Assess the primitive problem. One new product to improve the income. Okay, this one generating the new plan. Now, they want to do teh tarik halia. Okay, so brainstorm. What are the suitable ingredients that you need? What are the suitable ingredients for teh tarik halia? Tea, of course. Halia, ginger, of course. Water, of course. No water, no teh tarik. Sugar. Then? Huh? Milk. You need milk, not? Milk. Fresh milk or what? What type of milk? Okay, so you need to identify what are the ingredients. And then from there, process creation. How you want to mix them all? Add tea first or add halia first? Add sugar first? Which one come first? Which one come later? Okay, then after you identify that thing, development of base case is when the process flow comes in. Let's say you already finalized. We add tea first into the cup. Add tea. Then add water, hot water. It must be hot water. Okay, it cannot be cold water. Then add sugar. Add milk. Then tarik. Okay, tarik, how long to tarik? It have effect, right? You just tarik a bit, no issue, no effect lah, no bubble. Okay, so the longer you tarik, the more bubble you have, right? Then that one also make a good impression lah of the bubble, right? You see, right? Wow, you want to drink at that time. Okay, then finish part 1, where you already have your process flow. Part 2, you come in the detailed process synthesis. Now here, how much tea that you want to use? What type of tea that you want to use? Then sugar, how much of sugar? What type of sugar? Brown sugar, white sugar, stevia. Okay, and then hot water. What are the temperature? What is the temperature of the water that you need? Okay, is it tap water, mineral water, filtered water? Okay, and then oh, we miss out the ginger. Halia, how much of the ginger? 1 gram, 2 gram? Okay, and then it will affect on the flavor. Milk, what type of milk? How much of milk? Okay, and then, okay, this one is detail. To produce that hot water, what do you need? Kettle, right? So do you need to boil the water? Do you need to manually boil it using gas or electricity? That's all involve the cost. You need to consider. Okay, I just give the basic picture on how to design the process. Once you got the detailed process, then comes the detailed design. Okay, let's say the kettle, you want to boil the water. How big is the kettle? Is it, and then how is the flow of the water? Okay. Then can you optimize or not? The steam that come out from the kettle, can it used to to do something else. Okay, use the energy for something else. That is optimized. Then once you already come out with a detailed design and optimization process, then you can start the plant up. Okay, plant up. Plant-wide controllability over here is you can start the process already. Okay, you can start the process, you can sell already. Okay, so I just want to give you the understanding of the big picture of these stats. These stats are required in constructing the plant. Later for your PDP 1 and 2, at the end of your PDP 2, by right, we can already do the construction of the plant. That's why in last time I went as the evaluator, they call in from industry player to evaluate whether the process is feasible to be constructed. Okay, that's why input from industrial player is also important. We engineer, we so-called come up with the fundamental and detailed design. So the industry player, somehow like businessmen, if you pitch to them, do they interested to build the plant or not? They don't want to know the details. Usually for businessmen, they just want to know how much profit that I can have. And will it be, is it, I need to deal with the DOE, okay? Is it impacting the environment or not? Okay. Okay, these are the process flow. You can look through the detailed process flow. Okay, any question before we go to the example? Now we move to the example. Consider the need to manufacture VCM, vinyl chloride monomer. Okay, just now I said vinyl methyl chloride. Wrong. It should be vinyl chloride monomer. VCM with the typical primitive problem statement. Okay, this is the structure of the VCM. Vinyl stand for what? Vinyl. What does it mean by vinyl? Double bond. Two carbon with double bond. You still remember your organic? Okay, so vinyl is this part. Chloride, of course, chlorine. Monomer? One. Monomer. This thing only lah. Okay, we are producing the monomer, not polymer. Okay. If polymer, you will have this kind of structure, polymer. Okay. Now, this is the process design just now, process flow. Later, I will make it bigger. We look at the problem statement first. Now, an opportunity has arisen to satisfy a new demand for VCM, a new demand, on the order of 800 million pounds per year in a petrochemical complex on the Gulf Coast. Okay, 800 million. Now, the existing plant owned by the company produces only 1 million pounds per year. Since VCM is an extremely toxic substance, okay, it is recommended that all new facilities are designed carefully to satisfy the governmental health and safety regulations. This is the demand, market demand. Now, existing plant only produce this much. Current production. How they want to meet up the demand? There is demand, so they will income, profit. How do they want to make up to 800 million pounds per year? Existing plant capacity only can produce 1 million. That's a lot. Okay. What do you suggest? As an engineer, let's say, what do you suggest before we move to the next slide? Just want to know your opinion. What do you suggest? Now, you have 800, the demand from market is 800 million. You only produce 1 million. How you want to make up to that production? Scale up, one of the alternative. Scale up the plant. Okay, other than scale up, any other alternative? Build more plant. Okay, one of the alternative, let's say you build another plant for it. Instead of scale up the current one, you build another plant. Okay, that is one of the alternatives that can be considered. Any more? Just a rough idea from yourself. Later we will discuss. That too. Okay. So we go through the example given over here. Okay, these are the assessing possibilities. Refining the problem statement and generating more specific problem. Okay. Just now, just a random idea. Scale up, build another plant. So before that, we need to also consider how about the raw materials. Let's say if you want to scale up, how about the raw materials? Is it available in-house or can be purchased or you will need to manufacture? Okay. Then scale of the process. How about the current production? Okay, and projected selling price. How is it? Then location for the plant. Let's say you want to build another plant. So we must consider the location of the other plant. Okay. Okay, before we move to that, I want to highlight on the process over here. Okay, make it bigger. Now, this is the process of producing VCM. Raw material is the CL. Okay, CL, ethane. Output, the product. HCl is the byproduct. Okay, this is your main product. This is the VCM, main product. So you have byproduct HCl over here. The input would be Cl2, C2H4. Okay. Okay. Just understand this input and output, what you need. Now, from the slide here, it proposed these few alternatives. Now, to satisfy the need for an additional 800 million, of VCM. These alternatives might be generated. Okay, this one is from the given slide lah, and it is not limited to these alternatives only. Okay, first alternative over here, a competitor's plant. Can see now? Yeah. Student at the back. Can see now? Okay, a competitor's plant which produces 200 million pound per year of VCM and located 100 miles away. You have competitors which produce more than you, 200 million. Okay, might be expanded to produce the required amount. That competitors might expand their plant, which would be shipped, and then they will ship out their product. Okay, in this case, the design team's project the design team projects the purchase price and designs storage facilities. Competitors have 200 million pounds per year. You only have 1 million. So from this first alternative, the design team proposed that the company buy from this competitor's plant and store the product at current plant. Understand? Company A produce 1 million. Our company, say our company produce 1 million. Company B produce 200 million. You don't want to spend too much for expanding the plant. You just buy their product, then keep in our plant. So from there, you can only design the storage facilities. So you just, it involves the storage facilities only. You only build the storage facilities instead of you set up the new plant. Buy their product and store in our company, our plant. Then sell back that product. Okay, that is one of the alternative. So here, that's why here it mentioned projects the purchase price, the price that you purchase from that company B, then they design the storage facilities. Okay. Okay, here the term we can say it outsource the product. Other company that produce the product, you just buy and store in your company. Okay, outsource from competitors. Next alternative, the company produces HCl as the byproduct. Okay, from the PFD just now, we know that HCl is the byproduct in large quantities. Just now it's around 50,000 pounds. Okay, so thus HCl is normally available at low price. Okay, at low price. Reaction of HCl with acetylene or ethylene and oxygen could produce the intermediate 1,2-dichloroethane. An intermediate that can be cracked to produce vinyl chloride. Okay, here meaning that from your process just now you have HCl. Okay, as the byproduct HCl. Then this HCl you use with acetylene. Okay, let's say acetylene. What is acetylene? What is acetylene? How is the chemical structure of acetylene? Can you remember? Google. How it looks like acetylene. Yes, carbon, triple bond, carbon. carbon C, acetylene. Wait, sorry. I don't want to write it here. Later you confuse. Acetylene. Okay, so HCl react with the acetylene or ethylene and oxygen could produce 1,2-dichloroethane. Okay, from here it can produce, here I put here, the product dichloroethane. 1, 2. You should still remember your organic chemistry. 1,2-dichloroethane. Correct? Chemical structure. Dichloroethane. 1,2-dichloroethane. Correct? Right. Right. So this is the intermediate that can be used to produce the VCM, vinyl chloride. Okay, so from here we can produce the VCM, the intermediate. Okay, so that one is one of the alternative. You use your own byproduct. So that byproduct you don't need to sell. You just use it to produce your VCM. Okay. Now another alternative is purchased and shipped by pipeline from a nearby plant, chlorine from the electrolysis of NaCl solution. React the chlorine with ethylene to produce the monomer and HCl as the byproduct. Okay, chlorine as the current process, we need chlorine and ethane. Then you have HCl as your byproduct and VCM. Okay, so this is the current plant. Now here it mentioned purchased and shipped by pipeline from a nearby plant, chlorine from the electrolysis of NaCl solution. React the chlorine with ethylene to produce the monomer. Okay, this one similar to the current process, but here the alternative method is to purchase and ship by pipeline from nearby plant. Perhaps initially they buy from somewhere else. So to increase the production, you need a lot of Cl to react with your ethane. Okay, so alternatively, they want to buy from the nearby company that produce chlorine from electrolysis. Okay. Another alternative just now mentioned by your friend, scale up. Scale up the plant. So scale up the plant, so you should redesign your equipment or recalculate how many equipment to be added, how many op to be added. Another alternative just now to build another plant, right? Build another plant. So you just scale up the current design, build at another location. Okay, so this part is the brainstorm activity. Come out with the alternative. What can be done to meet that market demand? Okay. Okay, any question from here? Too much info. Cannot brain already. A few more slides. Okay. Okay, these are the references if you want to, let's say, scale up the plan. Okay. Many references lah, just a list of references. This one is once you set up the base case. Okay, once from the alternative just now, you select one the best. Which alternative is the best? Then you come out the base case. Create the flow sheet. Okay, then from the base case, we go for detailed process synthesis. Once you have the detailed process synthesis, you identify already the equipment that you need to use. Then design the detailed equipment. Sizing, everything. You take PED also, this time. PED. No, not yet. Yes. That subject will will be used after you come up with your unit op. Okay. So we have covered this part until the part 1. Okay, we covered the part 1 already. Any question before we stop the class? Can understand the concept? Okay, so for the lecture, that's all. For those who just now missed the attendance, these are the QR code. Already scanned? Okay, next class, we will continue on the environmental part. Okay, that's all. Thank you. For those, is there any more who cannot scan the QR? Is any error? For those who cannot scan, write your name over here. And attendance. Okay, that's all. Thank you.